What is a data analyst's favorite type of music? An algorithm. God, it's so dumb. I'm keeping it. This video is meant to serve as an introduction to this channel. Basically, I want to give viewers a better understanding of the concept of data ecologies. Ecology is a branch of science that deals with relationships of organisms to one another, as well as to their physical surroundings. It involves the study of ecosystems. Ecosystems are basically groups of elements that interact with one another. In the natural world, ecosystems can be huge, like the oceans or the Amazon rainforest. Or they can be tiny, like a compost pile in which bacteria, bugs, and fungi all compete for the leftover nutrients of humans. the, the Lion King was actually a great introduction to ecology, teaching us all about the circle of life. Basically, all life exists as part of various intersecting networks through which resources are shared and circulated. Humans, as well, also live in ecosystems. Just like a bee navigates its surroundings, interacting with flowers, plants, and other insects as it buzzes around, so too do humans navigate their surroundings, interacting with various objects and elements. A unique feature of human ecosystems, however, is that we have developed technologies which change how we function and which change our relationships with our environment. Things like fire and clothes and tools have all reconfigured how we exist within various ecosystems. Revolutionary technologies like writing or metalworking have radically altered human ecosystems. Take, for example, the humble plow. It might sound a bit far-fetched, but seriously, the plow was actually a pretty big deal back in the day, helping to shift humanity away from nomadic hunter-gatherer lifestyles towards more settled communities. Increased productivity, along with surplus food production, allowed for the development of art, culture, technology, and intellectual pursuits. Much of what we call civilization can be attributed to the ways in which the plow helped to reshape human ecosystems. Some other noteworthy technological breakthroughs which helped to dramatically reshape human ecosystems have included things like the printing press, the steam engine, penicillin, electricity, and more recently, the microchip. When trying to understand how technologies alter human ecosystems, a useful way to conceptualize our relationship with technologies is through the concept of socio-technical systems. It sounds kind of complex, but it's really quite simple. Socio means social, and technical relates to technologies. So, socio-technical systems are essentially systems in which people and technology work together to get something done. A slightly more advanced definition would refer to a socio-technical system as an interconnected network of people, technologies, and organizational practices that mutually shape one another to accomplish shared goals. But I kind of like the first one better. Socio-technical systems has actually become a pretty popular way of framing how technologies can change the way societies and organizations function. The idea itself can be traced back to a 1951 article written by a couple of ethnographers who went down into a coal mine to understand how new mining technologies were changing social and psychological dynamics among miners. Now, I don't want to go too deep into the mines, but that paper, titled Some Social and Psychological Consequences of the Long Wall Method of Coal Getting, an examination of the psychological situation and defenses of a work group in relation to the social structure and technological content of the work system. A mouthful. Basically, this article highlights how the introduction of a new coal extraction technology negatively impacted social dynamics and psychology of mine workers. The new socio-technical system associated with this new mining technology, it caused workers to report boredom, anxiety, and loss of pride in their craft. Human ecosystems are full of overlapping socio-technical systems. There are very few jobs out there which do not involve the use of some technology. To this extent, basically all jobs can now be framed as socio-technical systems. I recently went to the dentist and observed how the dentist's workflow involved a very specific set of actions, hierarchies, and technologies, all of which structured my dental experience. Today, the socio-technical system of a dental visit is deeply impacted by X-ray imaging, quirky metal probes, and dental assistants sucking the drool out of my gob hole. Gotta say, it's a big upgrade from medieval dentistry. Unless you live under a rock and never have to interact with another human being or technology, most of your daily routines can probably also be framed as various socio-technical systems. Hosting a barbecue, for example, is a relatively simple socio-technical system which involves me picking up my phone, opening up a messaging app, texting a friend, and then copying and pasting that text to other friends. And then, when my friends receive the message, they can open up their phones and they can tell me that they can't come because they're too busy petting their cats. Socio-technical systems can be studied on large scales and small scales. Higher education, or say a country's immigration bureaucracy, these are very large socio-technical systems. Well, the act of making a restaurant reservation or ordering an Uber may represent smaller socio-technical systems. So, getting back to it, you might be wondering, okay, so what does this have to do with data ecologies? Well, all of these socio-technical systems that I have mentioned, they've been deeply shaped by their data ecosystem. Data ecosystems are made up of the various infrastructures, institutions, and technologies which shape the data flows inside of a society. As technology progresses, socio-technical systems also change. Long ago, our barbecue example might have involved sending an invitation using paper, pen, and a functioning postal service. Later, it involved fixed-line telephone calls, the landline. Today, it involves texts. However, tomorrow, it might involve an AI system which coordinates my social activities without my input. In the distant future, maybe our uploaded brains will simply meet in virtual space. Again, the socio-technical systems of a society are shaped by the data ecosystem of a society, and the shape of a data ecosystem is negotiated through interactions between firms, governments, institutions, and technologies. In the current moment, datafication is the force which is radically changing socio-technical systems around the world, fundamentally altering human societies. What do I mean by datafication? Well, I'm referring to a trend which started around 2010, in which the amount of data that exists in the world has increased exponentially. This can be seen in the context of the so-called 3 V's of big data, namely volume, variety, and velocity. In terms of volume, as you can see, the amount of data that exists in the world began to increase exponentially, taking off again around 2010. If you study anything related to data, these are some charts that you are likely familiar with. It's basically the famous hockey stick graph from climate change. In terms of velocity, computer systems have been getting more and more powerful. I really like this chart from Sevilla et al.'s 2022 publication titled Compute Trends from Across 3 Eras of Machine Learning. This chart, it tracks the amount of training compute used by various machine learning systems over time. Basically, we can see that a deep learning trend began, again, in 2010. Finally, in terms of variety, we can see that 2010 launched the beginning of a new era of cloud-connected devices. This is where a lot of the data, in terms of volume, is coming from. IoT, or Internet of Things devices, include things like your smart TV, smart speaker, surveillance cameras, remote sensors, smart meters, smart supply chains, robot vacuums, and any other cloud-connected devices you can think of. Thanks to the vast diversity of modern digital technologies, as an individual goes through their daily life, streams of data emanate from their behaviors. Every interaction with technology creates more data streams. This includes everything you look up on the internet, everything you purchase with your credit card, all the music you stream, the podcasts you listen to, the videos you watch, even your location. It's probably being constantly tracked. Beyond individuals, corporations are also prolific custodians of data. Data streams have become deeply integrated in the way that organizations function and support operations at all levels of business. As many have observed, the very idea of a tech company has actually become a little bit blurred. Increasingly, nearly all companies are tech companies. So, zooming back out, all the way back out, what we're seeing is a global trend in which human ecosystems are increasingly experiencing a process of datafication. More and more daily human activities are becoming datafied, and digital technologies are becoming increasingly integrated into all aspects of society. Academics and philosophers of technology have come up with a variety of ways to understand these trends. Perhaps the most commonly cited conceptual framing is found in the term ubiquitous computing, which describes the seamless integration of data processing technologies into human environments. This term was first coined by Xerox chief technologist Mark Weiser in the early 1990s, who describes that it is invisible, everywhere computing that does not live on a personal device of any sort, but is in the woodwork everywhere. Ubiquitous computing, as a narrative, is often focused on the invisible nature of computing technologies, highlighting how forms of data processing now silently mediate the everyday functioning of societies. I think this is really well conceptualized in Adam Greenfield's work, Everywhere, The Dawning Age of Ubiquitous Computing, who describes ubiquitous computing as a new paradigm characterized by, quote, information processing dissolving in behavior. Another parallel concept is that of ambient intelligence. This is a narrative which emerged in the late 90s, likely out of Phillips research. The term actually became quickly enmeshed with the idea of innovation ecosystems and has been used as a directive concept which has shaped the research agendas of various technology companies and governments. Ambient intelligence adds a focus on adaptive systems which can respond to situational contexts. It describes systems which are capable of a high degree of personalization and proactivity. Ambient intelligence now pervades the technological visions of companies like Google, Amazon, and Facebook, who seek to further integrate personalized and adaptive technologies into the human environment. One of my personal favorite conceptual framings, it's actually that of mirror worlds, which was theorized in 1993 by computer scientist David Galanter in his book, Mirror Worlds, or The Day That Software Puts the Universe in a Shoebox, How It Will Happen and What It Will Mean. So, Galanter theorized that interconnected constellations of software systems would eventually create virtual reflections of physical reality. More recent discourse about mirror worlds, it tends to center around the augmentative qualities of smart environments. To this end, the concept is primarily deployed in the context of models, simulations, and virtual realities, as well as the range of possibilities that they enable. But again, I'm getting a bit sidetracked here. Coming back to the concept of data ecologies, we can basically see that data flows have now joined energy and capital as some of the primary structural features which shape how societies function and develop. In this regard, I think maybe the best way to think about data is as a factor of production. So, if you think about your Econ 101 class, factors of production are essentially the inputs to an economy. Economists typically identify factors of production as land, labor, and capital. These inputs to the economy are used then to create outputs, or goods and services. In Chinese political economy, data was actually officially recognized as a factor of production in 2020, providing the Chinese Communist Party with a certain authority over data management within China. If you remember, in communism, the means of production are owned by the people and should be managed to serve the interests of the collective. In a paper that I published last year, which I will soon turn into a video, I describe how the official designation of data as a factor of production supports the development of what I call data communism. If you want to watch that whenever it comes out, subscribe. In this context, data governance is now an increasingly important domain of statecraft. Governments worldwide are increasingly viewing data governance not merely as an administrative or technical issue, but rather as a key site for asserting sovereignty, altering economic trajectories, and pursuing strategic objectives. Data ecosystems can thus be studied on a variety of levels. As nation-states pass high-level regulation, we can now speak of the emergence of national data ecosystems. This includes things like Europe's General Data Protection Regulation, or GDPR, which restricts certain types of data flows, resulting in a much less creepy data ecosystem for European citizens. Meanwhile, in the US data ecosystem, we all just seem to be resigned to an understanding that someone is always collecting our data, observing everything that we do. Whether it's Google, Facebook, or the NSA, we've come to expect that digital privacy is kind of an illusion. It's important to note here that data governance is not limited to governments. In the US, there are no substantial data regulations at the federal level. The architects of the US data ecosystem are all corporations. However, it's not to say that data governance does not exist. Apple, for example, has been a noteworthy de facto regulatory power, limiting the data practices of Facebook and other social media platforms through its App Store policies. It's a common misnomer to assume that governance is done by a government, but this is not quite the case. Governance encompasses the processes, institutions, and practices through which decisions are made and implemented. It's a super broad way of thinking about rules and norms. Data ecosystems are thus constructed through interactions between firms, governments, infrastructures, institutions, and technologies. Data ecologies involve studying how all of these forces interact with each other. An ecological approach considers the way that data flows through individuals, devices, infrastructures, firms, organizations, and nations. It considers how changes in these data flows can affect power dynamics, social relations, and socio-technical systems. The study of data ecosystems includes state actions, such as data privacy regulation, state surveillance, censorship, age gating, antitrust. However, again, governance is not limited to government actions. Firm norms, practices, and behaviors are also part of data ecosystems. All of the various data collection and processing techniques that have been developed by Facebook, Google, Apple, etc., are also forms of data governance which reshape data ecosystems. This includes practices of data valence, the operationalization of behavioral surplus, algorithmic governmentality, data siloing, dark patterns, and end-user license agreements. These are all things which maybe I'll make a video about in the future. With the tsunami of new AI technologies washing over the globe, an understanding of data and technology governance has never been more important. Data governance and AI governance are essentially two sides of the same coin. AI technologies are trained on data sources, and many of the benefits of AI technologies are related to their ability to sort through and make sense out of big data. Regulatory interventions in data governance are also a form of AI governance. For example, when a society adopts more strict controls on the collection and processing of personal data, this can alter the trajectory of AI development. Companies need to access certain types of data in order to develop certain types of AI. Another big theme in data ecologies is that of institutions. If you're not a sociologist, economist, or political scientist, you might be wondering, what does he mean by institutions? Well, in the social sciences, institutions are sometimes described as the norms and rules which organize societies. This includes things like legal traditions, economic structures, and attitudes about data and privacy. Institutions play a substantial role in how a society distributes power and resources, and institutions coordinate collective action by signaling what is acceptable, obligatory, or forbidden in a given community. Importantly, institutions persist over time and provide a certain degree of stability and predictability within a society. The institutions of a particular society are heavily shaped by that society's history and culture. For example, the EU's General Data Protection Regulation, GDPR, can be linked to civil law traditions that protect honor and personality rights. Many of the European privacy rules are based on institutions which seek to protect human dignity and are designed to prevent any degradation or humiliation that could occur when personal data are exposed or manipulated. China's institutions, on the other hand, are very different, and much of the data ecosystem has been shaped by Confucianism. In the US, neoliberalism remains a powerful shaper of institutions which make up the US data ecosystem. And if you're interested in this case, definitely check out the work of Julie Cohen. In future videos, I will highlight many of the more interesting things that I've come across, both from my own research as well as from that of some of my friends and colleagues. My goal is to increase awareness about things that are happening around the world as societies navigate the challenges and benefits that data technologies can provide. For those of you who don't know, my PhD is in global studies. This is a relatively new interdisciplinary field which examines the systems, networks, and power dynamics that are involved in world-scale processes, including datafication. Basically, all societies around the world have begun moving forward with widespread datafication. However you personally might feel about it, our societies are becoming increasingly integrated with new data and AI technologies, despite a relatively poor understanding about the diverse risks and benefits that data and AI technologies might pose. We don't really know what lies ahead, but we're all in this together. And as we're heading into the unknown, it makes a lot of sense to look around and see what's going on, to check out what others are doing. There's never going to be a one-size-fits-all in the management of a data ecosystem, but a bit of transnational learning could be beneficial. Again, thanks for watching my channel. I appreciate the attention. Have a beautiful day.